Let's do this example. Determine every missing variable for a right triangle defined as the one shown. Be sure to draw the right triangle and correctly label each side A, B, and C, and each angle theta and phi. Express your answer using the correct significant figures. Let's start by sketching our right triangle. Our right triangle has sides A equal to 10 centimeters, B equal to 20 centimeters. The hypotenuse side C is unknown, nor do we know angles theta and phi. Let's start by finding side C, the hypotenuse. Remember, Pythagorean's theorem provides a relationship between the sides of a right triangle, and it says that the hypotenuse squared is equal to the sum of the squares of the remaining sides of the right triangle. If we want to find length C, we just need to take the positive square root of A squared plus B squared. This is just the positive square root of 10 centimeters squared plus 20 centimeters squared. When we plug this into our calculator, we get the square root of 10,400 centimeters. The problem says express our answer using the correct significant figures. Looking at the sides of this right triangle, A is to 2 significant figures because I see the decimal point fixes the sig figs for this problem. So A is to 2 sig figs, and the decimal point on B indicates that B is also to 2 sig figs based off of where that decimal point is. That means we need to round our answer to 2 significant figures. When I enter this into my calculator, I get 101.98 centimeters, but that's not 2 significant figures. To do it to 2 significant figures, we're going to have to use scientific notation. So scientific notation on this gives me C is equal to 1.0 times 10 squared centimeters, where we have now expressed C using the correct significant figures for this problem. Let's now find angles theta and phi. Let's now find angles theta and phi. Let's copy our sketch to this page and use this as the basis for our solutions. Now remember, the trigonometric functions sine, cosine, and tangent provides relationships between the sides of a right triangle and the angles, the complementary angles inside the right triangle. Here, I know side A is 10 centimeters, B is 20 centimeters, and side C, to 2 significant figures, is 1.0 times 10 squared centimeters. Let's find angle theta. Now, I'm going to use tangent to find angle theta. Tangent is equal to the side opposite that angle theta divided by the side adjacent to that angle theta. The reason why I want to use tangent is I see that A is our number to 2 significant figures. We didn't have to round side A, nor did we have to round side B. Side C, however, this form of our answer is a rounded result, so I want to avoid using rounded results when I can, And since we know that sine of angle theta would be opposite over hypotenuse, and since we know cosine of angle theta would be adjacent over hypotenuse, since both of these have that hypotenuse in it, and since we rounded our hypotenuse, I'm going to want to avoid using that rounded answer or use the exact form of our answer for side C. This is why I want to use tangent, because I didn't have to round side A and B. So tangent of our angle theta is side A divided by side B, which is 10 centimeters divided by 20 centimeters. The centimeters cancels. This simplifies to 1/2. Tangent theta then is equal to 1/2. To get an angle from this, we just have to apply the inverse tangent function. Theta is equal to the inverse tangent of 1/2. Let's enter this into our calculator. I'm using a TI-84 calculator. Let's clear. So we have the inverse tangent of 1 divided by 2. Before I enter this, I'm going to make sure our calculator is in degree mode. I see that it's in degree mode up here. If you're not in degree mode, if you're in radian mode, make sure you go over and hit mode. Third one down is going to be radian or degree. And actually, we want to make sure we are in degree mode, which we already are in degree mode. So if you're in radian mode, make sure you switch to degree mode. Now that we've confirmed we are in degree mode, I'm going to hit enter on our answer. I get that the angle theta is equal to 26.57 degrees if we round. However, the problem says express your answer using the correct sig figs. Well, remember, when the sides of a right triangle are to 2 sig figs, then you can round your answer to the nearest degree. The answer for an angle to a nearest degree. So I am going to round my angle to the nearest degree to be 27 degrees for angle theta. Now that we have angle theta, let's determine angle phi. Remember, angles theta and phi are complementary angles. What that means is they sum to 90 degrees. Since they sum to 90 degrees, we could use that relationship to determine what angle phi is. Angle phi is 90 degrees minus angle theta. For us, angle phi is 90 degrees minus 27 degrees. And this is just equal to, well, let's see. I think that's equal to 63 degrees. We have now found side C, angle theta, which is 27 degrees, and angle phi, which is 63 degrees.